Welcome back to the Math Professors. Topics here can be found in algebra, statistics, calculus, and so on. So if you like the free content and want to help us grow our channel, please consider liking, subscribing, and sharing. So a student came to me and asked me how to integrate the secant cubed of x dx. And it ends up actually being related to the integral of the tangent squared of x times the secant of x dx. So we're going to integrate this left-hand integral and then in terms find the the antiderivative or the indefinite integral of the secant cubed. So in order to do this, what I'm going to do is I'm going to break down this tangent squared of x into the secant squared minus 1 using the Pythagorean theorem. So what we know is the sine squared of x plus the cosine squared of x is equal to 1. So if I want to get a tangent squared, I'm going to have to divide everything by the cosine squared of x. So this gives us tangent squared of x plus this will give us 1 is equal to the secant squared of x. So that means the tangent squared of x is going to be the secant squared of x minus 1. So in this chart, I'll try to show it all. Then we're still going to multiply by the secant of x dx. Now when I distribute this is going to be equal to the secant cubed of x minus the secant of x dx. Now what I do know how to do is I know how to integrate that the secant of x, and it ends up being that logarithm. So if I want to do this over here, if I want to integrate the secant of x dx, what I'm going to do is I'm going to multiply the top and bottom by the secant of x plus the tangent of x, all over the secant of x plus the tangent of x dx. So this is going to give us the integral of the secant squared of x plus the secant of x tangent of x, all divided by the secant of x plus the tangent of x dx. So in order to do this, we're going to do it by u substitution. So what I'm going to do is I'm going to make, the denominator is going to be my u. So u is going to be equal to the secant of x plus tangent of x. And then when I find my du, the derivative of the secant is the secant of x tangent of x. And the derivative of the tangent is going to be equal to the secant squared of x. Now remember, I'm not taking the derivative, I'm doing the differential, so this has to be followed by dx. So you can see that this is the numerator. So this ends up being the integral of 1 over u du, which is the natural log of the absolute value of u, plus c. So this is going to be the natural log of u, which is the secant of x plus the tangent of x. So that helps us integrate this thing. So this is going to be minus that natural log expression. So in order for me to do this secant cubed of x, what I'm going to do is this is another by parts. So this is going to be equal to the integral of the secant squared of x times the secant of x dx minus, now we already knew that this is going to be the integral of the secant, which is going to be the natural log of this secant of x plus our tangent of x. Now remember that this entire thing is still equal to this integral. So let's just call this I, our target integral. So this is equal to I. So in order to integrate this, again, I need a u that is differentiable. So let's call it the secant of x, and then a dv, which is going to be integrable, which is going to be equal to the secant squared of x dx. So the derivative of the secant is going to be equal to the secant of x tangent of x. And the antiderivative of the secant squared of x is going to be equal to, I'm going to have to have a differential here. And then v is going to be the integral of the secant squared, which is going to be the tangent of x. So now we know that its integral is uv. So this is going to be equal to uv minus the integral of v du. So uv, which is going to be equal to the secant of x times the tangent of x minus the integral of v du. Now v is going to be tangent, du is going to be tangent, so we're going to get a tangent squared secant of x. So this is going to give me tangent squared of x times the secant of x dx, which is really the beauty of this integral. Now remember, we still have this natural log over here, so minus the natural log of secant of x plus tangent of x. I know plus c, but we'll get there when I do all the other antiderivatives. Okay, so this is kind of the beauty of this is I know that our target integral I is equal to this piece right here, and notice that I have that piece again. So since we know that I is equal to this, when I subtract this is also equal to I. So when I send this over here, I actually have two of my target integrals, or two of these things, is equal to the secant of x tangent of x minus, that natural log of the secant of x plus the tangent of x. I guess I might as well put my plus c in here, plus c. Okay, so remember, I don't want two of those target integrals. I want one of those target integrals. So dividing everything by 2, I have my target integral I is going to be equal to the secant of x tangent of x divided by 2 minus 1/2 the natural log of the secant of x plus tangent of x plus c. Okay. Remember, I also wanted to be able to find the integral of the secant cubed function. So let's erase our work on the integral of the secants, and then kind of see how I can integrate this secant cube function. Well, I know that, then let's call this guy I2 then. I sub 2. So this target integral, which is the secant cubed, which we actually already tell that it's, it's already in this particular integral. So what I know is I can see it right here, that let's kind of rewrite this, that the integral of the tangent squared of x times the secant of x dx is equal to the integral of the secant cubed of x dx, and then minus the integral of the secant, which is going to be minus the natural log of the secant of x plus the tangent of x plus c. So in order to integrate this thing, I really just have to isolate it, and I already know the value of this thing. The value of this is right here. This is just I. So I'm going to put this. I'll just send this to the other side. But when I write that, I'll write this as integral of the secant. Actually, let's just write this as I2. So this is I2. So I2, which is the integral of that secant cubed, is going to be equal to the integral of the tangent squared of x, secant of x, minus, actually not minus, but plus, because I have to send it over, the absolute value of the natural log of the, the natural log of the absolute value of the secant of x plus tangent of x plus c. Okay, and then again, remember, I know this value. This value is equal to I, so this is equal to, 1/2 let's just rewrite it. The secant of x tangent of x divided by 2 minus 1/2 the natural log of the absolute value of the secant of x plus tangent of x, and I still have plus 1/2, sorry, not plus 1/2, but plus this natural log of the secant of x plus tangent of x plus c. So negative 1/2 plus 1 is going to be positive 1/2. So finally my I2, we'll write it down here, is going to be really almost exactly this thing, except instead of a minus, it's going to be a plus. So the integral of the secant cubed is going to be equal to the secant of x tangent of x divided by 2 plus 1/2 the natural log of the absolute value of the secant of x plus tangent of x, all plus c. So I hope you enjoyed that. That was a very interesting set of integrals, and I like their relation to each other. So again, please consider liking, subscribing, and sharing.